Hey there, everybody. Welcome back. We're looking at cylindrical triple integrals. We got an example for you. This is Calc 3. Let's just jump right into it. We got this integral. Our function is the square root of 1 plus x squared plus y squared. Our inner integral looks like it's dz from -1 to 2. So z is going from -1 to 2. It's not a function of x or y. That's nice. Our next integral is dy, and this y squared in here, it's not going to be all that easy to integrate this. I don't want to treat this as 1 plus x squared as a constant, because it's not. Y is a function of x. So maybe we could toy around with it. If I look at it, I know I can see by inspection, this would be 1 plus r squared. So if I switch to cylindrical, I would have an r dz dr d theta. And I can see if I do a u sub with 1 plus r squared, I'll get the 2r, and we'll deal with the r, and we'll have a way to go forward from this. So I like the idea of going with polar on this, or cylindrical. Let's just work that out. What do the y and z components tell us? Y is saying that, well, it's between these two. When you have a negative and a positive on the equal sides of the sandwich inequality, it is the same thing as the absolute value of the middle thing less than or equal to the positive one. So I square both sides, and I get x squared over, and I see this is a circle with radius square root of 8. So I drew a picture of a square root of 8, a radius with square root of 8, centered at the origin. And then my x component says go from 0 to 2 root 2. 2 root 2 is square root of 8. So it looks like we're just doing this right half right here. X is positive. So that tells me how we're doing it. If we switch to cylindrical, what do we got to do? Our radius should go from 0 out to square root of 8. And our angle should go from negative pi over 2 to pi over 2. So let's set that up. We already talked the 1 plus r squared and r dz dr d theta. I've got my integrals in terms of theta, r and z. That u sub we were talking about, 1 plus r squared. We get 2r dr. I've divided the 1/2 over already. So we have 1/2 du equals r dr. So I got the 1/2 out here. The r dr is right there. Those go in replace of du. This turns into a u. Square root of u is u to the 1/2. And I redid the limits on u so I wouldn't have to switch back to r. When r is 0, u is 1. And when r is square root of 8, u is 9. So we redid the integral limits on u. This is a separable function. I have no variables in the limits of integration, and it's a product. So I separated it out. I've got a d theta integral, put the 1/2 with that. I've got the u to the 1/2 du from 1 to 9, and then negative 1 over 2 dz. If you work this out, you will see that you get 26 pi. Ta-da! So pause that video, work it out, and I'll see you on the next video. Peace.